Right, okay guys, so we're just going to look at the alkanes very quickly. This is the stuff that you should have been looking at over the last couple of lessons that you were doing by yourself. So this is kind of an opportunity just to watch and see what you need to know about this so far before we move on to the next bit. Excuse me. So things you need to be able to do is talk about the names of the alkanes, the structural formulas, basically what it looks like, the chemical formula, short and structural formula, which we'll maybe touch on a wee bit, but I'll do more of later on, and the general formula as well. So we're only dealing with alkanes 1 to 8, which is quite good because it's quite a manageable number. So in the first instance, I'll just write down all the names of your alkanes just to remind you before we go on to the more complicated bit of this. So we've got ethane, propane, butane, pentane, hexane, heptane and octane. So what you actually need to be able to do is remember those prefixes. A lot of people get them mixed up all the time, so it's maybe worthwhile making up a wee mnemonic or something like that just so that you remember them. Some of them are easier to remember than others, so things like oct, so obviously octopuses have 8 legs, so that's a kind of easy way to remember that one. So the next bit is your full structural formula. So we've kind of looked a wee bit at this already whenever we were doing Unit 1, whenever you were building compounds using the Molly mods and things like that. So this is where it's really important that you know all your valency rules and things as well, so tying everything in with Unit 1. So I'll do a couple of the full structural formulas just so that you can see how you would actually do that and what it actually means, just in case you've been looking at it and thinking, right, I get how to do it, but I don't really understand what it is. So if we go for methane, so let's get 1 carbon in it. So we know that carbon's in group 4, so we know that the valency is 4. So in other words, that's going to mean that it'll make 4 bonds. So each carbon always makes 4 bonds. No more, no less than that. So that's your full structural formula for methane. So you can see that it's actually showing you the bonds between your carbon and hydrogen atoms. Okay, so that happens 4 times in your methane molecule. So if we go for one more, maybe one of the kind of longer ones, we've got hexane, which is 6 carbons. So again, the easiest way to do that is just draw 6 carbons in a row and then fill in all of your hydrogen atoms. So just making sure that you've got 4 bonds coming out each carbon atom at all times. Okay, so sometimes it's a bit of a pain to draw in all these hydrogens. It does take a wee while, but the more you do it, the more practice you get, the quicker you get at it. Okay, so the next bit is chemical formula, which you've all done before as well in Unit 1. So in Unit 2 it's quite straightforward compared to what we would have done in Unit 1. So all you need to do is count number of carbons, number of hydrogens, and that's you sorted. Okay, so if we go for propane, for example, so we've got C3, 3 carbons in it, and again making sure that the numbers are subscript. Let's help if I can spell. Which again, just remember that, so that just means that it's on a kind of lower line than your element is. Okay, so it's kind of slightly smaller number. And then again, if it helps, just draw it out. But we'll get to the general formula in a minute, which will actually allow you to work out what the chemical formula is. So C3H8 is your chemical formula for your propane molecule. So short and structural formula is a wee bit trickier. Like I said, we're going to do a wee bit more of this as we're going along because we've got other groups of compounds we're going to look at. But I'll just show you one very quickly just now. So if we go for butane, okay, so the trick is to kind of draw out the full structural formula so that you can see clearly what is going on. Okay, and all the short and structural formula is what it says in the tin, right? It's a shortened version of what we've just drawn out. So the way to do that is basically just circle each of your carbons like so, and then all you're doing is writing down what is round about each carbon atom. So for the first one, we've got 1 carbon and 3 hydrogens, and then if we go over to the next one, that's just CH2, next one CH2, and the next one CH3. Okay, so that's what shortened structural formula is. It does get a wee bit more complicated than that, but that is it for the moment. Okay, so if we quickly just look at the general formula, so that, I know that some of you in the short test weren't too sure about that, the wee Microsoft form thing that you filled in, but that's absolutely fine. So all you're really doing there, it's just a pattern, right? So if you had to write out all your chemical formulas for the alkanes, so for example, if we had methane, which is CH4, and then ethane, which is C2H6, and then propane, which is C3H8, you can actually start to see, if you write out enough of them, that there's a pattern emerging. So some of you might have done patterns and things like that in maths, and that's all it is. So the general formula for the alkanes is Cn H2n plus 2. Okay, so basically all that means is that however many carbons you've got, which is the n, right, so n can be any number, it means that there's going to be twice as many hydrogens plus 2, right? So for example, if we had an alkane, one that you're never going to be asked about, right? So imagine n was 100. What you can do is work out the chemical formula of that alkane. So all you need to do is plug in n 100 into this formula. Okay, so if it was C100, you can work out number of hydrogens by multiplying it by 2, which is 200, but then remembering add that 2 on as well, so it would just be 2O2. Okay, so take a breather, you can pause the video just to make sure that you understand all of that before we go on to the next bit, okay? Okay, so the next bit is a wee bit more complicated, but if you know the basic stuff, it should be okay, and it actually is one of the most straightforward things to be doing at National 5. So the things that I want you to take away from this video are the naming rules, okay? So very important that you do this step by step so that you don't do anything wrong. So the main kind of things that you should be able to do after this is draw branched alkanes. So branched alkanes are kind of more complicated than the ones that we've just looked at. So these are all straight chain, the ones that we've looked at. So branched alkanes are a bit more complex than that. So you need to be able to draw those and name them as well. So a couple of things to be doing here. So set of rules, which are down at the right hand side. So if we have, for example, butane, right? I just want to put this into context just so that you know what I mean by the term branched alkane. So if we've got 4 carbons here, we've got butane, right? But if I draw a similar structure like this, it's got 4 carbons in it, however, it's not butane, right? So these two things are completely different compounds, right? So they'll act very differently as well, even although they've got the same chemical formula. So the chemical formula for butane, C4H10, and it's the same for this one that's not butane as well. Okay, so what we call that is an isomer. Okay, so things with the same chemical formula but different structure, but we're going to talk about that later on after we've learned how to name these things here. Okay, so that's why you've got your list of rules involved with that. Okay, so the first step is to identify the longest chain of carbon atoms and name that after the appropriate alkane. So for example, in this one, if I just change the colour of the pen so you can see what I'm doing here, all you're having to do is identify which carbon chain is longest in the molecule, right? So in here we've got 3 carbons in a row, so we'll just say that that's our longest chain, and we name that after the appropriate alkane. So the alkane with 3 carbon atoms is propane, so I'll just write that over here just now, just to keep ourselves right. Oh. Number 2, so number the carbon atoms starting from the end of the chain closest to the branch. So what that means is you need to number all your carbons that are in your molecule. So you need to identify your branches first. So this carbon here is the branch. right? So it's kind of branching off of the main tree trunk, if you like. So what we're doing here is numbering the carbons. So in this one, it doesn't really matter what side we start numbering from. So I'll just start at the right hand side. So that's carbon 1, that's carbon 2, that's carbon 3. Okay, so we've done that, so that's fine. So that's step 2 done. For step 3, so name the branch from the number of carbon atoms in the branch. So we've already identified what our branch is. It's got 1 carbon in it, so that is called a methyl branch. So notice that meth again, okay? So that is the prefix for 1 carbon. So just always kind of remember that and you won't go wrong. Step 4 is use di and tri as a prefix to the branch name when there are more than one of that branch. In this example, we've only got 1 branch, so we don't really need to worry about that just now, so that's not appropriate or applicable. Number 5 is basically the last step where you're putting the full name together. So you're adding the position of the branch, name of the branch, and the name of the chain together. So what you're actually doing here is writing down your longest chain, which is propane, add in the name of your branch, which is methyl. So it's a bit strange initially kind of writing backwards, if you know what I mean, and then add in the position of the branch. So basically what carbon is that branch on. So in this, it's on carbon number 2. So all we're doing here is pop my number 2 in front and a dash. Okay, so that molecule isn't butane, it's 2-methyl propane. So what I would do just now is maybe just take a second, pause the video and go through the rules, maybe take a wee note of them, take these molecules down as examples just to show you that if you come across an alkane with 4 carbons in it, it might not be butane depending on what the structure is. Okay, so if you want to pause just now and then we'll try some harder ones. So if you look at another quick example and then I'll get you to try some in a second. So I'll just quickly draw this molecule here. It's making it a wee bit harder, but not by much. These do sometimes get quite tricky, so that's why you always need to follow the rules. So for just now, we're kind of keeping it nice and simple. So identifying the longest chain first. So in this example, we've got 4 carbons in a row. So we'll just circle that just to keep us right, and we'll write that down just as we're going along. So that's butane. Number the carbon atoms starting from the end of the chain closest to the branch. So the reason why I showed you this one is just so that you can get into your head where we're numbering carbons from, right? So in this example, our branch is here. So what you need to start thinking about is what side you're going to number from. So in this example, we're numbering from the right hand side, okay, because your branch is closest to the right hand side. So that's carbon 1, that's 2, that's 3, and that's 4. So same thing again, so just looking at the name of the branch, so that's a methyl branch because there's only 1 carbon in it. We've only got 1 of them, so we don't need di or tri in there, so we'll just pop methyl in just now and add the position of the branch, so it's on carbon number 2. So pop your 2 in front and then your dash. So that was just to show you the numbering carbon thing before we do anything else, okay? So a couple other examples, I'm just going to run through these very, very quickly and then I'll leave you to try them. If you want to pause the video just now, you can, and you can try them first and then you can look at the answers if you want to do that, if you're feeling pretty confident. But there are a couple of wee things with these ones that you just need to watch out for. So we'll start with number 1. So in this case, we've got quite a long chain. We've got 5 carbons in our longest chain. So a thing I would say is just make sure you're always checking which chain is the longest, right? So what you can actually get is sometimes your molecule can bend round corners. So actually this could be the main chain, or this could be the main chain here. Okay, so just always go in every direction you can just to see if there's a chain that's longer than the one that's straight. So I'll show you a couple of examples of that in a wee second. So I'll just delete that just now. So in this one, our longest chain is pentane. So if you just pop that down, keep yourself right. Numbering your carbons, so starting from the right hand side, so you've got a branch here and a branch here. Okay, so this one's 2 carbons away from the end, but this one is only 1 carbon away from this end, so we start numbering from over here. So this is where it gets a wee bit trickier. So this time we've got 2 branches, which are both methyl. Okay, so we've got 1 carbon in each, so it's not an ethyl group, it's still a methyl. Okay, so it's just methyl, but because there's 2 of them, we would pop a di in front of that this time. So the numbering as well, so remember you're kind of trying to identify where these branches are in the molecule. So we've got 1 on carbon number 2, and we've got 1 on carbon 3 as well. So all you would do there is just put a wee comma in, the number 3, and then a dash. Okay, so that one there is 2,3-dimethyl pentane. So well done if you tried that before looking at the answer. So number 2 is a wee bit trickier. People get caught out with this all the time, and that's why I've put it in there, just so that you can see how you can actually get trapped up with this. So looking for your longest chain first, you might think, right, okay, so we've got 3 carbons in a row here, that's your longest chain, and then we've got an ethyl group and a methyl group. That's actually not the case, right? So for this one, if I just take that away, if I know how to do it, give me a wee second. Don't know what's going on with this. Right, so I eventually got that deleted. Sorry about that. So that the 3 carbons there aren't your longest chain, right? So what actually can happen, like I said over here, is that the molecule can bend, right? So what you've got is this big long chain here. So this is actually just hexane. Right, so even although these look like branches down here, they're actually not. So bonds can rotate and they can bend and things like that. So you're not always going to have a straight chain in a straight line, if that makes sense. So just watch out for that one. Okay, so if you're not sure about that, just let me know. So number 3, again, looks very complicated, but again, it's the same thing. So you're just looking for your longest chain. So looking in every direction to see, so we've got carbon 1, 2, 3, 4, 5, 6. So 6, you've got quite a long chain there. Check from over here, so we've got 1, 2, 3, 4, 5, 6. So 6 does actually seem to be the longest chain here. So if we just circle that again to keep ourselves right, so we know that's hexane as well. But this time we've got this wee branch coming off as well. So what you're doing here is numbering your carbons from the closest to the branch, which is over here, the left hand side this time. So that's carbon 1, that's 2, that's 3, that's 4, 5, 6. So what you've got is a methyl branch on carbon number 2. Okay, so nice and simple, even though it looks more complicated. Now this one down here, so this is the last example I'm going to do for you, and then you can try some yourself. So again, longest chain first, so looks as if this big long chain here is the longest chain. So again, just making sure that you're going in every direction, counting it, seeing what the longest chain is, and remembering about the bending of the bonds at the end. Okay, then you've got your branches here, 1, 2, 3, 4, 5, 6, 7. So that's heptane, which is your longest chain. And then again, you're numbering from the left hand side this time, because your 2 branches are closest to the left. Okay, so you've got 2 of them, so we've got dimethyl, and they're both on carbon 2 this time. So what we do for that is we actually need to write the number 2 twice. Again, that's just to specify where these branches are, because you could have one branch on carbon number 2 and then one on 3 or 4 or whatever, so you need to actually specify that they're both on carbon number 2. Okay, so again, just you can copy these down if you want, just to make sure you've got loads of different examples. So that's the kind of things that would trip people up. Okay, so pause the video, you can try these ones for naming the ones that are given and drawing from the name as well. So just a wee hint for that, because we've not really looked at that, but draw the long chain first, so the kind of end of the name first, and then add in your branches once you've numbered your carbons. So if you pause, we'll go through the answers in a second, okay? Right, okay guys, so here's all of your answers for the ones that you've tried. So we've got 2,2-dimethylbutane, 2,3-dimethylpentane, 2,3,3-trimethylpentane, and then the 2 are drawn at the bottom for you. Okay, so if you want to just check that you got those right, well done if you got them all right, and you can let me know if you got them right as well, because I will be asking you just to see how you've got on with this. So if you feel like you need more practice, which you probably will because it does take a wee while to get this into your head, there is a worksheet on Google Classroom, Show My Homework. It's not going to take you that long, it's just maybe 5 or 6 questions just getting you to practice drawing and naming from the structure. If you could answer all your questions, you can do it on something like Microsoft Paint or something like that if you want to do that, or you can do it in your jotter and take pictures. Ideally, if you could submit it via Show My Homework so that I can keep all of your stuff together. If not, if you can't get access to that, then you can email me it or you can post it on the Teams as well. It's up to you. And I'll get it back to you as soon as possible. So if you get that done by the 4th of May, and that'll give me a good idea if you've actually been kind of keeping up with what I've been doing. Okay, so quite a lot of info, so just take a bit of time, digest it, get some notes written, and then do a wee bit of practice. Okay, so that is it for naming branched alkanes.